Hello everyone, it's June 26th, Saturday. Ooh, take a deep breath. I ate some fettuccine alfredo this morning. Completely vegan. Tastes amazingly good. But now let's face the challenge. It's gonna be a hard question as usual. Ooh, let's go for it. I got nervous. Alright. Count of smaller numbers after self. You're given an integer array nums, and you have to return a new counts array. The counts array has the property where counts I is the number of smaller elements to the right of numbers I. So counts I is the number of smaller elements to the right of nums I. So to the counts 0 would be 5, so the number of elements to the right that's smaller, so it's 2. That would be 1, that's 1, that's a 0. Honestly, it didn't feel that complicated. I don't feel like this is a difficult question though. Okay, a naive solution, O(n) squared, right? For each one, we go from everything. Each one will go from everything, but then we definitely are repeating some of the logic. What is the last one? Definitely be 0, right? So if it's this one, so if we go back to front, let's say we know how many, we know the number of, so here we know the number of elements that is smaller than 6, and if this value is larger than this value, then this count will be the count of this plus 1, right? So that one we already solved, which means 2 have 1, so 5 must have 2. 1 has 0, so 6 must have 1. Now the only problem to solve is if this value is smaller than this. If I am smaller than this, then I need to look for a number that is myself minus 1, right? Myself minus 1. So we need to look for myself minus 1, which means as we go from the back to the front, we can keep track of each element. We keep track of the most recent element. What if it doesn't exist? That is a good question. What if it doesn't exist? We cannot keep searching. We can use binary search, which means we need to keep a sorted list of all the values. A sorted list. How can we keep a sorted list? We can't. So the question is, how do I find, right? How do I find a value that is smaller than myself, right? That's smaller than myself, that occurs the first, like a closest to me. That is the question. Maybe like a monotonic, something like a monotonic stack, something like that. Would that help? On a monotonic stack, how does a monotonic stack do? So if something is larger, then I just pop. Because the large values, we don't care, right? If I'm larger than you, then I know my answer. Actually, no, I don't know. I don't know. It has to be, I have to be only one smaller. If this is like a, yeah, this is actually not true. Like, so I know it's smaller than 2, but I don't know how many is smaller than 3, how many is smaller than 4. They should all be included in 5. So no. But it is to find the value that is smaller, just smaller than, like find 4, if 4 exists. But what about the values in between? Count, right? We can do count. But if we do count, like if we count the number of occurrences of each numbers as we go through, like 1 occurs once, right, and then 6, then we'll have to look for from 5 to 1, the total number of occurrences. But then you have to add all of them together. You have to check every single one. That doesn't feel right. Hold up. If I give a value, I already know the total number that's smaller than that. And I give a new value. The new value, so what we want to know is, for the new value, if my new value is larger, then I'll include everything than that one can. And I also need to include everybody that's just smaller than me. Can we use priority queue? Like when I'm looking at 5, I have like all of these. What if I save all of these inside a priority queue, and I'm gonna pop out the largest? I feel like some type of technique that I used in the past that didn't really work very well. Well, this is not easy. Okay, so I feel like it feel like dynamic programming to me. The number of elements that's smaller, right? The number of elements that's smaller. Number of elements that's smaller. Given a value x, right? And it's at this position, at I position, and then I have certain number of value that's smaller than me. And then if I know this, right, I know xi, I have the value, and now we're looking at I minus 1, a new value of y. Can we obtain, just based on this information, we say if x is equal to y, then the value is the same. If y is 1 larger than x, and the value is whatever x is plus 1. If y is much bigger than x, that's the problem. Because we don't know, or we should try to find how many values that are larger than me, right? How many values that are larger than me? So I come in, how do I know how many values are larger than me? So when I come in, if I am large, do I pop up everything else? Like I'm saying, if it's always the current largest, so we always store the current largest value. Right, so if I have a larger value, then I pop it out, right? But I also have the indices. That means when I encounter this, it's like what I see is always the largest, right? The largest. When I go in and if there's something smaller than me, I'll pop them out until I encounter the ones that are bigger than me, right? And then I can compute my value by counting the indices, right? The indices from myself to the one that's bigger than me, and then indices between the remaining. Okay, okay, that seems reasonable. Indices, right? Indices. So between the indices, they are the ones that's smaller than me. It is a monotonic. It's a monotonic stack. We keep tracking of the biggest value so far. Everything smaller will be just gone, right? So what if I have a small value coming in? If I have a small value coming in, what I know is from me to, because currently when I enter the stage, right? When I enter the stage, what's remaining is the current biggest from current uh, biggest that's occupying, right? Current biggest that's occupying. So in a descending order, in a descending order, right? In a descending order. If it's in a descending order, from the right to the left, it's in a descending order. So when I come in, if I'm big, then I pop out a small. So make sure it's still a descending order. So know that the values between me and the next bigger one, they're all smaller than me, right? So when a small one come in, it didn't work. If I am small and I come in, I don't know how many is. Yeah, it doesn't seem right, huh? What does the monotonic do? So a bunch of values, and we go, if the last one is small, big, I say I don't want small, small goes away. So I know from this to the right, everything is smaller than this, right? And then the next one, if it's big, I'll also everything to the right is smaller than this. So this is the current largest, right? Everything to the right is smaller than this. And then if I have, what you find if I have something larger coming in, right? If I have larger coming in, and then all I need to know is the difference between these two, and or pop it. Difference between these two, and pop it, and then if there's nothing more, then it's from this to the end. Right? Yeah. So if something really big coming in, we can solve it. If something big, I mean like big, then the current biggest. No, the current. Okay, so if I have something else, and if I'm bigger than the current biggest, we say we include everything in between. Oh, we include everything in between, and we pop this. This one has everything that's smaller than this. If I have everything smaller than this value, I can have, right? But then the question is, in between this and this, how many is larger than this but smaller than me? That I do not know. If there is something that's bigger than this, oh, that would be the first one that's bigger than it. Now we have double count. To count something smaller than that, right? We encounter the first thing that's something smaller than this. Who is at the front of the stack? The stack's like this, right? If I think about a stack like this, and then I come in, and then everybody knows the number that's smaller than myself. Then I'm bigger than this, which means everything in between me and this, right? When I add this, that's easy to do. After that, I include everything that's smaller than this, right? And then